top of 9-2, the first section is really simple. You're just converting from logarithm into exponential form. The second set, you're converting from exponential into logarithm form. And the third set, you're evaluating each logarithm using your calculator. So number 35 says log base, what is it? 2 of 16 equals 4. Oh, well, I know what it equals. So in your calculator, you're just going to do ln 16 over ln 2. And I want you to write this down because I want you to get used to doing that. On the test, you have to write that down to get credit. So you'll write that down and then you'll write down the answer, which in this case is 4. The last two have variables in them. So your calculator won't tell you an answer because it's a huge range of numbers. So you'll just write down this version like if there's an x in there or something like that. You can't actually solve it. You can just evaluate it like that. And then the last set is pretty easy. You just kind of have to think about what's going on. So a logarithm has 3 parts. Let's say we have log base a of b equals c. 3 parts a, b, and c. And depending on which part is missing, you have to change your solution strategy to figure out what the answer is. So let's say I had log base 3 of x equals 4. How am I going to solve that? No, so you're trying to split them. The only time you can split a logarithm is if there's 2 things multiplied right there. We just convert it into exponent. In the exponential form, it would be 3 to the 4th equals x. So the answer is just 3 to the 4th, which is 81. Okay? Well, what if a is missing? Log base 5, oh my goodness. I gotta stop doing that. Log base 7, I did it again. Okay, log base x of 216 equals 3. So if my a value is missing, how do I solve that? Divide. So you're trying to use the product or quotient rules? Right, I just convert to exponent. X to the 3rd equals 216. And then how do you solve that? Take the 3rd root. Well, the 3rd root of 216 is 6. Okay? Well, what if c is missing? Log base 2 of 8 equals x. Well, you could convert it. 2 to the x equals 8, but then that didn't help. So converting it didn't work. You're overthinking it. It's just ln x over ln 2. So you just use this. Or ln 8 over ln 2. So if a is missing, convert to exponent. If b is missing, convert to exponent. If c is missing, just use the change of base formula. Ln of the number divided by the ln of the base. Okay? Well, if you look at 9.3, it says log base 5 of 2 equals 0.4307. 9.3. Top of 9.3 equals 0.6826. Okay? Now, we don't have to do this anymore because we have calculators, but this is a good exercise on problem solving, so we're going to solve these. So it says, if you know only those 2 values, well, that's not true, we know a third one, can you figure out, and I don't want to use any that they used, Okay. Can you figure out what the log base 5 of 6 equals? Well, can I create a 6 using a 2 and a 3? Yes, so this would be log base 5 of 2 times 3, right? Well, if I have log base 5 of 2 times 3, can I split that? Yes, it's the log base 5 of 2 plus log base 5 of 3. So in my calculator, all I would have to do is add 0.407 plus, what's the other one? I can't see it. Oh, I missed one, sorry. 307 plus 0.6826. So it's kind of in two parts. First of all, you have to figure out how to use a 2 and a 3 to create the given number. Once you have that created, then you split it according to the product and quotient rules, and you're adding or subtracting. Okay? Well, there's another trick that I'm going to teach you just in a second. Okay, so let's say we have log base 5 of, let me make sure it's not on the worksheet, 12. Well, 4.5. Can you use a 2, can you use 2's and 3's to create 4.5? It is possible. You could make a fraction out of it. What would you make? What is 4.5 as a fraction? 4 and 1/2. Okay, mixed numbers died a long time ago. What is it? 9 halves. Can we make a 9 halves using a 2 and a 3? 3 squared over 2. So this is log base 5 of 3 squared over 2. Everybody understand that? Okay. Well, this is going to be, really, it's 3 times 3. So we're going to use 2 of those. What are the signs of those? Positive. And we're going to use one of these. What's its sign? Negative. So it's 2 times 0.6826 minus 0.4307. Does that make sense? So it's the log base 5 of 3 plus the log base 5 of 3 minus the log base 5 of 2. Okay? So, what if we did log base 5 of 15? How could we create a 15 using a 2 and a 3? What's that? So we could do, so this could be log base 5 of 3 times 2 plus 3, right? Well, can I split that? I can, but I would split it into log base 5 of 3 plus log base 5 of 2 plus 3, which is 5. So adding the numbers together is never going to help. Okay, that doesn't work. But you have stumbled on something. If I change that to a 5, can I split that? Yes, log base 5 of 3 plus log base 5 of 5. Do I know what log base 5 of 5 is? It's 1, right? Because a logarithm just represents an exponent. So 5 to what power equals 5? 1. So in addition to these two, we always know that log base a of a equals 1. Therefore, log base 5 of 5 equals 1. So we're allowed to use 3s and 2s, and in this case 5s, because that's the base. All right, so if I wanted to do, well, I'm just going to clear this out. If I wanted to do log base 5 of 40, can I create a 40 using 2s, 3s, and 5s? How would you do it? Log base 5 of 2 to the third times 5. And I'm allowed to bring this out front of the 2, not the 5. So 3 log base 5 of 2 plus log base 5 of 5. So this is 3, oops, 3 times 0.4307 plus 1. Does that make sense? Yeah? So you kind of have to be creative, and often there's more than one way to do it. If you're making it really, really complicated, there's probably an easier way. But you're allowed to use 2 and 3 because they gave them to you. You're also allowed to use 5 because we know that log base 5 of 5 is 1. Yes? No. If if 3s are all you need, that's fine. Yeah. Yep. It's kind of like saying if your calculator only had 3 buttons, a 2, a 3, and a 5, and you're not allowed to use addition or subtraction, can you come up with a given number? Well, you don't have to use the 5, but if it comes in handy, then go ahead and use it. Okay. Um, look at number 25 on 9-3. Okay. So what we have here are 2 logarithms added together equaling a third logarithm. Can I use the product rule to simplify this? Can I simplify these? Yes, what would it be? Log base 3 of 5x equals log base 3 of 10. No. Well, does anybody notice a shortcut to solving this? Yes. Why? Well, if log base 3 of this number equals the log base 5 of that number, what do we know about these two numbers? They're the same. So, to quote Tom Hansen, and this is his favorite thing to say in an Algebra 2 classroom, if the logarithms have the same bases, so you have a logarithm equals a logarithm with nothing else, you can drop a log. It's just Tom. That's Tom Hansen's. So I can drop, because they're the same bases, I can drop them, and I'm just left with 5x equals 10. And then you solve for x. But if it was like log base 3 of 5x equals log base 3 of 10 plus 1, now I can't drop the logs. Okay? And it says check your solutions. I wonder why it says that. So if I plug in 2, is log base 3 of 5 plus log base 3 of 2 equal to log base 3 of 10? And the answer is yes. Why did they make me check? Well, something tricky happens. So look down at number 33. There's a big difference between 25 and 33. Do you notice the difference? Well, I can still combine it. So let's combine the left side. Log base 10 of z times z plus 3 equals 1. What's the difference here? Well, okay, yeah, we'll get to that. What's the difference between number 25 and number 33? It doesn't equal a logarithm. Can I drop the logs? No, because I only have one. I need one on each side in order to drop it. So, how do I solve that? Speak up. 10 to the first, right? Remember back when I said log base A of B equals C? Well, if B is unknown, what's our strategy? Convert it to exponent. So converting this to exponent, I get 10 to the first equals z times z plus 3. So if you have logarithms on both sides, use the product rule and then drop the logs. If you have logarithms on one side, use the product or the quotient rule and then convert to exponent. Well, this is just a quadratic. Z squared plus 3z. What do I do with the 10? Subtract it. So I get minus 10 equals 0. Are there factors of 10 that add to be 3? Z plus, z minus. What was your question? Oh. Okay, so what are my roots? -5 and 2. Now, it asks you to check your solutions. So let's try it. Let's plug in 2. So we have log base 10 of 2 plus log base 10 of 2 plus 3 is 5. Well, if I combine those, I get log base 10 of 10, which is 1. So 2 worked, right? So let's plug in -5. Log base 10 of -5 equal or plus log base 10 of -5 plus 3 is -2. If I combine those, I get log base 10 of -5 times -2 is 10. Does that equal 1? We cheated. There's something we haven't talked about yet. I want you to plug log base 10 of -5 into your calculator. So ln -5 divided by the ln of 10. Or I guess you could have just done log of -5, right? Error. So what this is asking is, if I set this equal to x, 10 to the x equals -5. Why is that an error? Well, if I square it, it's going to be positive, right? But what if I cube it? It's still positive. How come? So how many 10s do I need to line up before I reach a negative number? It's impossible. If your base is positive, no matter what your exponent is, whether your exponent is negative or a fraction or a whole number, we can change the size of the 10. We can keep multiplying by 10 to make it bigger. We can keep dividing by 10 to make it smaller. We can keep taking square roots of it to make it smaller, but there is no way to use 10s and create a negative using only multiplication and division. So whenever you have a negative here, the logarithm ceases to work. So what that means is, even though algebraically we found an answer, that one is not part of the solution. Remember back when we were doing rational expressions and we would get two numbers and we had to test to see if they made the denominator 0? This is the same idea. Okay, you always have to look at your answers in logarithms to make sure that it doesn't create negatives in the original problem. If it does create negatives, then you cross it off. If it doesn't, then it is your answer. So you're saying, could we have log base -5 of -125 equals 3? So that does translate into -5 to the third equals -125. And while that is true, because the negative rules are different with even numbers and odd numbers, and fractions are even more messed up, we don't include those as part of the domain of the function. So what we say is that those numbers are not part of the logarithms. Technically, you could do that. Well, let's see what the calculator says. Maybe the calculator will be nice to us, but you never know. 125 divided by the ln of -5. Yeah. So in some cases it works, but you have to remember that squares work different than thirds, and fractions are even a more mess. You kind of have to look at the denominator, so it's awful. So we just kind of forget that negative bases even exist with logarithms. Okay? So we limit bases to numbers greater than 0. Well, actually, we don't even let 1 work. Log base 1, there's only one answer. You can only do log base 1 of 1. Because, did I talk about that yesterday? Okay. So, log base 1, the only number that works is 1. You can't get anything else out of that. All right. So, you've got the long weekend to work on these. Hopefully you finish them in class so you don't have any homework. Okay, good luck.